Okay, this is going to take a look at eccentricity of ellipses. So what is eccentricity? Without a graph on hand, how would you explain to someone else how elliptical a particular ellipse is? So if you had to choose between A, B, and C, if you were explaining this to another person, how would you tell them how elliptical something is? So I would say B is the most elliptical, but how could we quantify this? So it says in figure A, the ellipse might easily be mistaken for a circle. In a circle, the foci are equal to the center, right? Because a circle, everything is equidistant from one center point. Therefore, when foci are extremely close to the center, it is difficult to make a visual distinction between a circle and an ellipse. Early astronomers had a difficult time when studying planetary orbits whose foci were relatively close to their centers. Now we use the concept of eccentricity. Eccentricity is C divided by A. What are C and A? Remember, C is the distance from the center to a focus, and it's on the major axis. A is the distance from the center to the end point of the major axis, right? The vertex. So for an ellipse that is nearly circular, the foci are close to the center. So that means that this C value is very, very small, like 0.01. And you're dividing by a big number. So if A was 6 or something. So a very small number divided by a larger number is going to approach 0. So a circle actually has an eccentricity of exactly 0, right? Because C is 0. In an elongated ellipse, the foci get closer. Oh, wait a second. This is a typo. The foci are close to the center. The foci are close, I'm going to say further from, I apologize, typo. The foci are further from the center. So the ratio C divided by A is actually going to approach 1. So let me just kind of illustrate that. Here's my foci in an elongated ellipse. Here is C. Here is A. So if A, let's say, is 10 and C is maybe 9, 9 divided by 10 is 0.9. That's very elliptical. It's very close to 1. And it says eccentricity can never equal 1, because then you actually would have like a squished flat line on top of itself, right? There wouldn't be any space to go up. Right? A and C cannot equal each other because then there'd be no B value going up. All right, so we're looking for eccentricity. Is it close to 0 or is it close to 1? So an eccentricity might be 0.2. 0.2 is pretty close to 0, circular. But 0.8 would be very eccentric. Eccentric comes from the word odd. You know, like I have a very eccentric neighbor who has 12 cats. Anyway, eccentric is referring to how oval the ellipse is. So this says, let's find the eccentricity of each ellipse below and which ellipse has the greater eccentricity, and explain how their graphs will compare. So eccentricity is C divided by A. So for each of these, I need to determine C divided by A. So I'm going to use that Pythagorean identity that A squared equals B squared plus C squared because I need to find C. And it looks like A squared must be 9 in this equation and B squared must be 4 in this equation. So 9 has to equal 4 plus C squared. So 5 is equal to C squared. I subtract 4 from both sides. So the square root of 5 is equal to C. So I'm going to take the square root of 5 and divide by my A value. 9 was A squared. So A by itself is just 3. So what do I get as an eccentricity? Square root of 5 divided by 3 is 0.75 as an eccentricity. So you might want to pause the video, try finding the eccentricity for ellipse B on your own. So now I'm going to do the work. Let's see, a squared is 20. That's equal to b squared plus c squared. So I get 5 equals c squared again. Square root of 5 is c, but my a value is different this time. So when I do c divided by a, let's see, 20 is not a perfect square, so I'm just going to divide by the square root of 20 and see what I get. So what is the square root of 5 divided by the square root of 20? 0.5. Which eccentricity is larger? The 0.75. So this is going to be more elongated ellipse, more elliptical, closer to 1. All right, so to check your understanding of eccentricity, I would pause the video and see if you can determine the eccentricity to number 1 and number 2, and then unpause the video to check your answers. So now I'm going to find the answers. Let's see. A must be 50. So a squared is going to be 50 squared. B squared looks like it would be 14 squared. So this is just A and this is just B. So I have to square those to get A squared and B squared. So I'm going to take 50 squared, subtract off 14 squared. So I get 2304. Now I'm going to take the square root of that final number. So I took 50 squared, subtracted 14 squared to the other side, got 2304, took the square root. I know now that C is 48, and I'm dividing by A, which was 50. So that is pretty close to 1, isn't it? 48 divided by 50 gives you an eccentricity of 0.96. That's very, very eccentric. All right, number 2. Looks like I've got an A value of 1, 2, 3, 4, and a B value of 2. So A squared equals B squared plus C squared. That means that 12 is C squared, and C by itself is 3.46. I'm dividing by an A value of 4. This is still pretty elliptical then. 3.46 divided by 4 is 0.865. So, I mean, these are both very elliptical, very elongated. This one slightly more so. This is really, really narrow ellipse. So that is what you need to know about eccentricity.